Hello everyone, in this video we will learn all about Introduction to Basic Calculus. The only constant in this world is change. Now we see a lot of changes in the world every day. It could be from a speeding car, it could be from the changes of the prices in basic commodities, it could be in the change of the weather, or it could be in the population of people that changes every now and then. Now, it would be great if we can predict how things are going to change. Calculus is a branch of mathematics that can do this. Calculus is a mathematics of change. It is dynamic, in contrast to algebra and pre-calculus, which is static. It also enables us to model real-life situations. Now, let's try to compare and contrast situations without and with calculus. Now, given this speeding car here, without calculus, basically, some basic questions that we can ask would be, what is the average speed of the car? Now, if the car travels at 25 kilometers per hour and it drives for 2 hours, so basically in 2 hours, the distance covered is 50 kilometers. Now, in real life, we cannot always assume that the speed of the car is always constant. So from time to time, the speed of the car will change. So with that, one question that we can ask with calculus would be, what is the instantaneous speed of the car at 1 hour and 30 minutes? So again, as I've said, realistically, the speed of the car changes from time to time. So at 1 hour, the speed is different. After another hour, it will also change. So that's where calculus will be used in order to deal mathematically with the changes in the speed. Okay, another. Now, given this graph, without calculus, we can ask, what is the height of the curve when x is negative 2? Now, with calculus, we will ask, what is the limit of the function as x approaches negative 2 from the right or from the left? So again, as I've said, calculus is a mathematics of change. Okay, another for area. Now, given this rectangle here, one question we can ask is that, what is the area of the rectangle? So to be able to do that, to get the area of a rectangle, which is basically length times width, would be to draw squares. So with that, there are 5 squares in the width and the length is 3 squares. So all in all, with this given rectangle, there are 15 squares, or it's 15 centimeter square. Now, not everything in real life is a rectangle, a triangle, a square, or a circle. A lot of shapes in real world are not really a perfect polygon or not really a circle. So with that, for example, given this is not really a polygon because it's curved like at the top. Now, with this, how are you going to find the area with this? So with calculus, you will see what is the area of the shaded portion or in between curves. So again, common to us if we are asked to find the area is to draw squares. So with this, it's not always applicable to this. It's because, again, there are some parts here wherein the square cannot really be perfectly sketched. So with that, calculus again is used in finding the area of irregular shaped figures. Okay, another. Now, given this, we have here a balloon. So one question we can ask here without calculus is that what is the volume of the sphere of the balloon? Now take note, the formula for sphere is volume is equal to 4/3 pi r cubed. Now, it will be different if the balloon is being deflated. So take note, as the radius of the balloon changes, its volume is also affected. So with that, what then is the volume of the balloon as it is deflated? So calculus is used in finding the volume of this sphere as the radius changes. So again, there is movement or there are changes along the way. So that's how calculus is used. So we will learn that in the next videos. Okay, another. So there are key concepts or key tools in calculus that we will be using in order to solve problems involving changes. So the first is limits of a function, another is derivatives of a function, and the other one is the integral of a function. So going back to limits of a function, it is used in finding the limits as the function approaches a value. So take note of that. Now, when you say derivatives of a function, it is used in describing how a function changes. Okay, then the last, for integral of a function, it is used in finding the area between curves. To be more specific, it's area of irregular shaped figures. Now, if we will use all the tools in calculus like the limits, the derivatives, and the integral of a function, there are a lot of real-life situations or problems that we can use. One example is that where to sit in the cinema for optimal viewing. That's one example. Another would be, at what angle should one start firing to be able to hit a certain target? So we can make use of calculus to be able to identify answers to this particular questions. Calculus can be challenging to study with new ideas, terms, procedures, and processes, but one can learn it, for it provides a better way to describe the world around us, especially when it comes to change. So that would be all.